Okay, welcome to our IEPC webinar series. Before we begin today's webinars, I would like to give a very brief introduction about our association, which is called International Association for Bridge and Structure Engineering. Or briefly, we may call IABSE or IEPC. IEPC's mission is to exchange knowledge and advance the practice of structural engineering worldwide. All aspects in structural engineering, all types of structures and structural materials, all aspects of the construction process. As you know, the International Association for Bridge and Structural Engineering was founded in 1929 in Zurich, Switzerland. The current president of IEPC is Tina Verum from Denmark. IEPC is a scientific technical association comprising members in 100 countries and counting 60 more national groups worldwide. IEPC deals with all aspects of structural engineering, as I mentioned before. IEPC has the following objectives, but I don't think which is limited only these 4 objectives. For this purpose, the association organizes conferences worldwide, published high-quality journal, Structural Engineering International, SEI, published books reflecting the work of its technical groups, creates technical groups, offers the possibility to join activities within national groups of IEPC, offers a program for young engineers, and presents annual awards. Most importantly, IEPC launched webinars in 2021 during the COVID-19 pandemic. If you like to see some webinars previously conducted, you can take a look at this website. For today's webinars, I would like to give a very brief introduction about the speakers. Of course, my name is Yojing. I'm a moderator in this webinar presentation. Today's webinar speaker is Ms. Li Yao. She is a senior engineer in China Southwest Architectural Design and Research Institute Company Limited in Chengdu, Sichuan Province, China. She is a national first-class registered structural engineer. Since graduated with a master's degree, he has accumulated 10 years of professional experience and has completed over 15 designs of large-span special structures. She has participated in and completed 2 national-level research projects and won multiple survey and design awards, as well as science and technology prizes. With a long-term focus on the scientific research and engineering design in large-span special structures, she has published over 20 papers and more than 20 patents. Today, he is going to talking about to us is innovations and breakthroughs behind the world's largest glass lightning roof, Dong'an Lake Stadium, which has been selected in the finalist of IEPC Award for Large Building Structures 2025. Now, I would like to invite Ms. Li Yao to give us a speech.
Okay, thank you. Now, okay, can see the screen?
Not yet.
Is it okay? Can you hear me?
Yes, good.
And see the screen?
It's good.
Okay. Okay, good morning, good afternoon, good evening, everyone. It's my great honor to attend today's sharing session. The title of my report is Innovations and Breakthroughs Behind the World's Largest Glazed Lighting Roof, Dong'an Lake Stadium. This is our lead structural engineer, Feng Yuan. She has completed over 100 designs of long-span structures. She has put a great deal of effort into the design and research of Dong'an Lake Stadium. This is our team. Oh, okay, sorry. Can you hear my screen? Is it okay?
Yeah, we can see the screen.
Okay.
We can hear you clearly.
You can hear my screen, okay? Okay, this is our lead structure engineer Feng Yuan, and this is our team. We are honored to have been awarded the title of National Outstanding Engineering Team. These are the large span projects we have designed, covering sports buildings, airports, exhibition facilities, and more. These are the venues of the 31st World University Games. The report is divided into 4 parts. The 31st World University Games has been held in Chengdu. The Chengdu World University Games features 18 sports and 269 events in total, including athletics, basketball, swimming, and diving. These competitions are held in 46 sports venues in Chengdu. Our institute has designed 10 out of the 12 newly built venues. Dong'an Lake Stadium was the main venue for the opening ceremony. It's located in Longquanyi District, Chengdu. When we started the design, we asked ourselves what we wanted to share with friends from around the world. Only 3 countries in the world have a history of more than 5,000 years, and China, as one of them, is home to rich and time-honored history and culture. The Gold Sun Bird is a national treasure of China, dating back to the Shang or Zhou dynasty. It's a symbol of life, freedom, and unite. Chengdu is renowned as a park city. Up to now, it has built more than 1,456 parks of various types. We put together all the design concepts, and that's how the Dong'an Lake Stadium was created. The top of the stadium presents the gold sunboard pattern. Total area of the roof glass is 27,000 square meters, which is assembled by 12,540 pieces of colored glazed glass. It's the world's largest assembled project for glazed glass denighting roof. It's a Grade A stadium with 40,000 seats. The diameter of the roof is 295 meters. The overall highness of the roof is 45 meters. Innovations and breakthroughs of the project. However, enlarge the golden pattern of the sunbird by 2.7 million times and present it perfectly on the roof brought great challenges to the design team. The roof is assembled by 12,540 pieces of colored glazed glass, and carved roof glass requires high precision processing and installation. All colored glazed section shall post shading performances in daylight and shall ensure that the lighting project maintains light performance at night. We went through many color adjustments for the colored glazed alone, all to achieve the perfect shadow. Finally, a new type of colored glazed coral trapezoidal glass was invented. A complete manufacture process for colored glazed glass without non-uniform thickness coating solved the problem of achieving equal light transmittance for colored glazes of different color.
通过分段压块的形式固定在双层熔乳结构上，面积约27000平方米，共有。
This is a video of the roof.
562种双层采用，通过10余次材料打样试验，使采用玻璃达到最。
In order to perfect showcase the gold sign bird, we put in a great deal of work. Compared with the traditional metal roof and membrane roof, glass roof has a great load. The up and low point create structural heat, and grid division are considered as variable parameters, and the optimal force transmission path is explored through the optimized algorithm. The most effective structure solution is obtained through thousands of iterations, building form, and structure stress. As a result, the steel consumption of the cabinet is optimized by 30%, using the least material to complete the design of heavy roof. Glass has no ductility, and due to the spacing requirements, the precision standard is extremely high. Therefore, the main structure needs to be shaped into an arc according to the design form. Therefore, all the code members we see are arc-shaped. Each member has 4 to 5 shape control points, which are used in both design and procession stage. In order to perfectly realize the sunbird pattern, one of the annual truss is located at the boundary between the sun and the bird, this station, and the other truss evacuates the bottom cord to provide out-of-plane support with web members. At the same time, efforts are made to achieve the alignment relationship between the glass unit and the rod to reduce impact of excision roof lines. With innovation construction method and the integration of digital technology, the production and installation of 20,514 pieces of colored glazed glass in 631 specifications were completed, with accuracy doubled and an error of only 1 to 2 millimeters. An extreme puzzle was finished at higher altitude in just 35 days. achieving zero divisions and zero error rate. This is the night view of Dong'an Lake Stadium in the evening. Thanks to the glass material, the sun gold board shines with an extraordinary brilliance, as if this ancient symbol has been brought back to life in the modern stadium. The glazed glass of the roof has the function of light diffusion, and the interior is treated with frosting to avoid direct sunlight on the venue and reduce ultraviolet radiation. In addition, glass has good durability and self-cleaning properties. The acoustic ceiling member on the bottom chord of the roof mirrors the signboard, creating a contiguous circle canopy with an outer circumference of about 900 meters. The bottom chord features high transmittance sound above absorbent members with a transmittance rate of 41%, which allows nature sunlight into the venue during the daytime. During the evening, it can be used as the projection rain screen for the performing lighting show, casting a splendid interplay of arctic light and shadow, while reducing noise pollution. This is the opening ceremony of the World University Games. The stadium achieved a global first by facilitating a director and prolonged fireworks displays with hundreds of ignitions points on a large-scale glass roof. There is no reference engineering experience. The performance of glass on the different load type is highly complex, include reaction force exerted by fireworks load on glass. The induced structural vibrations under the influence of fireworks loads, and the stress distribution within glass panels. A series of tests and experiments has been carried out. Next, X-9 heavy-duty viewing platform enabled to overlook the beautiful scenery of Dong'an Lake. 3 extra long viewing platforms were incorporated into the stadium roof. The combination of external viewing platform and steel structure roof creates a new architecture model for the stadium structure. To enhance the circle stiffness of the roof, support is required, especially the outer ring of the roof. Clearly, the periphery circumferring to bracing exert a significant negative impact on the vision effector. In response, the structure design innovators by setting up dislocated interrupter V-shape structures to transfer the force. This means limited the stiffness of the keyboard's consist in the vertical traffic tube and the implant stiffness of the platform instead of the outer ring support. The structural relationship between the steel roof, extra line platform, facade grids, concrete stands, and vertical traffic tube is extremely complex. The 4 vertical traffic tubes on the south side connect the 7-meter elevation platforms and the 29-meter elevations platform. The 16 elevation view platform on the eastern and western sides connect the facade arcing single layer across grid and the grindstone structure. Here, just here. The facade arch ring layer cross grid is supported by the 7-meter elevation platform. Here, create a labyrinth of structure independence. The platform brought about a series of complex problems. Just here, this ring with 15 type of joints on the inner ring. And the platform is connected to the concrete, and diffusion coordination is required. And here the platform with 5 types and 23 cross sections. A series of complex analyses have been conducted on this platform due to its considerable length and the deformation of concrete and steel structures. The weaving platform experienced significant temperature-induced stress. To address this, the structure model that accounts for the 3-dimensional temperature field is established. Encompass interaction, develop and find design methods to ensure the structural integration and functionality of the design. This is the photo of the weaving platform. Beautiful views of Dong'an Lake can be seen from the platform. Share some beautiful photos of the Dong'an Lake. The single layer cross grid with variable converter and variable cross section. The building has 2 key requirements: a large inclination, curved facade, and multi-elevation heavy load platforms. These requirements made the design very challenging. The mechanical properties of various grids are compared. To maintain the optimized building memberships, we used a combination of hyperbolic circular pipers and long grid variable diamond line circular pipers. For the upper hyperbolic circular tube, we divided it into 20 segments. For the lower straight circular tube, the division is 5 segments. These points are then used as positional control points in member processing. To the end, solve the problem of loading bearing on the platform facade and achieving a perfect achievement effect. This structure works well. It handles heavy loads, looks good architectural, and keeps the structure safety and reasonable. These are several key joints in the load-bearing cold facade grid structure. First, the small angle joint. Second, the joints in the middle where circular and rectangular tubers cross. And third, the inclined support joints of the load-bearing grid at the bottom. All these joints make sure the structure transfer force reliable. This is the distribution location of each key joint. Abacus was used to perform finite element analysis of the typical joints. The calculation results of typical joints are shown in the picture. Meanwhile, we conducted a finite element analysis of each joint in a single truss. The complete effector of the single layer called the cross grid is shown in the picture. The third part is the low carbon design and construction technology. This stadium is characterized by its special architectural shape, along with numerous structural members, complex joints, large size, heavy weight, high precision requirements, and a tight construction period. We can see that the structural members are very large. Digital design and construction were adopted, with all information integrated into a single data model, considering the integration of design and construction. Design stream that take construction into account. Construction methods that consider mechanical performance. At the initial stage of design, the roof was designed as a perfect circle and is divided into 88 standard units. Achieving the standardization and modularization of the structure system and the curtain wall system, giving full plan to the advantages features of high efficiency industrialized prefabrications and assembly, greatly reducing the on-site construction process. We developed a detailed construction schedule. The standardized installation shelf are used. It not only improve efficiency, but also ensure excellent installation precision. They form a streamlined workflow, and the Intel projector is similar to assembling a large Lego, which greatly improve construction efficiency. We use materials with a low carbon emission factor. The main structure members adopt a cross-section with low carbon emissions. Select materials locally to shorten transportation distance. More electrical equipment is used during construction. Meanwhile, efforts are made to increase encryptor turnover rate and reduce costs. In order to meet the demand for low carbon design and reduce the amount of on-site construction work, all 40,000 stands adopted the method of prefabricated assembly, which means 100% factory customized production without cast-in place or decorations. What's more, the high-altitude platform adopts steel truss floor slabs, dispensing with the concrete formwork and construction support. This is a photo of the construction process. The construction period of the project is extremely tight, with only less than 2 years from construction to operation, while the average construction period of similar projects is 3 to 4 years, which posed a great challenge to both design and construction. The entire construction process also went through the test of the COVID-19, with many challenges overcome through joint efforts. Through a series of technological innovations and multidisciplinary collaborations, this unique and classed project was completed in less than 2 years to welcome the grand economy of the World University Games. In July 2023, the opening ceremony of the 31st World University Games was held at Dong'an Lake Sports Park Stadium. This stadium integrated advanced technology with traditional Chinese culture, embraced the global youth with a splendid Chinese romance. This is the opening ceremony of the World University Games. The fireworks display at the opening ceremony. This is the sacred flame, a symbol of sportsmanship and international friendship. Now, you may be wondering, what will happen to the Dong'an Lake Stadium in the long run after the World University Games? We know stadiums often face the challenge of idlers post-events. Don't worry, this was already considered at the initial design stage. Full consideration has been given to the possibility of future expansion and the conversation of usage for the stadium of usage screen for the stadium of Dong'an Lake Sports Park. Multi-elevations around heavy loaded viewing platform have been designed, not only used for sports events, but also consideration to multi-loads such as lights, wires, screens, sounds, fireworks, and emergency power supplies to meet various functional requirements in international sports events, large-scale performance, comprehensive exhibition, cultural museum, tourism, and sightseeing. Dong'an Lake Sports Park launches a variety of public benefits activities, aiming to enrich the spiritual and cultural life of local residents, making the sports park a vibrant public space that integrates sports, culture, and community interactions. The Dong'an Lake Sports Park has hosted over 100 large-scale events and created a significant economic value. The member in the roof can be used as a projection ring screen for the performance lighting show, casting a splendid interplay of artistic light and shadow. The park, where the stadium stands, is now China's largest ecological sports park, where the water within the lake is purified through a biological plant chain. Also, a comprehensive rainwater recycling system is adopted for the huge building, showcasing the stadium's dedicated to sustainability and the ecosystem health. This is the scenery of the Dong'an Lake Stadium. With the joint effort of all parties involved, the project has also won numerous honors, received the China Construction Engineering Luban Prize, received the Golden Award of China's Construction Engineering Steel Structure, received the first prize of Sichuan Province a Provincial Science and Technology Progress Award, and so on. At the same time, it has also obtained a number of patents, published many papers. The stadium has also received wide acclaim. CCTV has also covered Dong'an Lake Stadium on multiple occasions and produced several documentaries about it. For those interested, you can gain a deep understanding of the stadium through these videos. Through the design of this stadium, we have found that while achieving the beauty of architecture, the structure itself can also be a part of the beauty. Welcome to Chengdu, and welcome to Dong'an Lake Stadium. Now I will share a video. Okay, that's all for my report.
Okay, thank you very much, Ms. Li Yao. Very interesting and very scientific, presentations talking about the design, construction, and also low carbon technologies in this kind of stadium, which is called Dong'an Lake Stadium. So now I would like to have some questions or comments, if you like to have, from the audience and also from our panelists. Yeah, you can find the Q&A box if you have some questions. You can put there. I can read the questions to the speaker if you have. So probably first I would like to ask the questions. You mentioned for this kind of elevations of heavy loaded platform, you must be supported very strong foundations or columns, something like that. So what is the main problem for this kind of structures for very heavy load, but you would like to have lightweight roof structures?
Okay. Okay, we come. Let me prepare the PowerPoint. We used the single layered cross grid with the variable coverage and variable cross section, and we compared various grid such as vertical, monoclinic, and cross. We finished many analysis to complete which structure is the best. And finally, we find the single layer cross grid with variable coverage and variable cross section is good for the shape and have the best variety. So we chose this structure.
So you choose the single layer for its lightweight and also maybe strong support for those heavy loading. Well, now I find the first question from the Q&A box. You can see right here. The question is, where is the platform in the structure?
Oh, okay. We have three platforms in the structure. Two platforms and the 16 elevations on the eastern and western sides, and one platform and the 29 meters elevations on the south of the structure. The platform at the 16 meters elevations are located in the east and west. And to ensure the building is functional, the web members in the noise platform have been designed to be vertical, and numbers attempts have been made to arrange the members, and we get the good function, building function, and also it's very beautiful.
Okay, thank you. Now the second question I found it from the Q&A box. Were any special considerations taken from wind and seismic resistance in the structure design of the stadium? Which means wind resistance and earthquake resistance.
Yeah, I want to share because we have the glass in the up and the members in the lowing point. So oh, the wind I want to share the okay. Double-sided synchronous pressure wind tunnel tests have been taken in our projector. It's special and it's different from other stadium and the seismic we also take because the stadium is in Chengdu. We all know here has many earthquakes, so it's very important. And the fall life the phone life structure has monitoring is set in the stadium. We have record the earthquake, the data of the earthquake, and this is useful for our further design.
So is there any seismic resistance, kind of the testing you made for this kind of stadium? For any, seismic
Yeah.
resistance testing? Yeah.
The full life structural health monitoring is used in our structure. Just like Lushan or the real earthquake is happen and the structure is okay.
Okay, thank you. The next question is, what are the main aspects of multifunctionality for this kind of stadium? Which means not only for sports stadium itself, but maybe have some other kind of function.
Oh, okay. This question mainly with the two parts. One is the ultra-long platform. We have received various loans such as exhibition, catering, shopping, and equipment rooms. This platform can be expanded to serve multiple functions, including exhibitions, sightseeing, catering, and cameras. The other I want to say is the roof, such as lights, wires, screens, signs, fireworks, and emergency power supplies were considered to meet various functional requirements of international sports events, large-scale performance, comprehensive exhibitions, concerts, and tourism. They are all okay for Dong'an Lake Stadium. The member in the roof can be used as a projector screen for the performance lighting show, just as we see in the PowerPoint. And we think it's very multifunctional.
Okay, I just saw some photos in your presentation. They are very beautiful fireworks. So what kind of lightweight roof materials you used? And how could you make this kind of materials fireproof?
The roof is used
Yes.
glass. glass,
One.
and the glass is two level. The outer one and the inner one, and between them is the air. So it's light, and also have the strings for the ability to stand the loads.
So how could you make this kind of materials fireproof? Because it's, in fireworks must be very high temperatures and even burning, something like that.
Oh, we have take many experience, and we can take many tests and experience. We also vary if the glass is is not usually used in the fireworks. So okay, and the fireworks loads on glass is the stress distribution within glass panel. We don't know what it will be. So the test and experience is only the good method way for us to check the how is it okay? Is it okay?
And also one question from myself I would like to ask. You said you try to keep this kind of structure in economies, both in cost and carbon. So how much cost you saved compared with the traditional design, and how much you saved for the carbons, this kind of emission?
Half, about half, because the time, the period of the construction just less than 2 years, and the people, the workers, and the machines used also be less than other stadium. We have the circle, and divided it into 88. And it's the same. It's just like a standard, and so the process may be easy and maybe faster than other stadium. So we finished the task in 23 months.
Okay.
Mm.
Okay, one more question is coming. The question is, what kind of testing is done for wind and earthquake load, considering the stadium structure design is very complex? What kind of testing has been done for the wind and
Okay.
earthquake?
Okay. For the wind, double-sided synchronized pressure wind toners tests, toner tests. It test because I am when I just said we have two sides. For the first, the outer is glass and the inner is the member. So we master test the both. Yeah, the both pressure. And for the semi the joints test is about the the CMYC is take, and the for life structural health monitoring is also put into the stadium.
Okay, you mentioned for joints. I saw in your photos, in your presentation slide, there are many kinds of joints. So the first question maybe is how many members you should put them together in one joint? How many members?
I remember the 12 is
Okay.
Mm.
Always the same directions or different directions?
Yeah, different directions.
Mm-hmm. So maybe have very complex structures even in design and manufacture, I believe. Okay, now we can accept maybe the last question. The last question is coming, which is if building information technology, BMI, technologies are used in the design, were they implemented in the construction organization sections?
Okay.
So maybe it could be divided into two questions. The first question, did you use any kinds of beam model? The second question is how could you use this kind of beam models in construction organization?
Okay. We use the we use the beam model. In the beam model, we share the most the various information, the design information, the construction schedule, and the number of every members in the share. If we have some mistakes, we may check we may use the beam model and find the problems and solve the problem quickly. All the informations we used in a single data beam model.
Okay, thank you very much. Due to the time, I don't think we can allow any further questions. So thank you very much for your very interesting and very informative presentations talking about Dong'an Lake Stadium, which has been selected in the finalist of the IFC Award for Large Building and Structures 2025. And we hope you can win the IFC Award in November 14. Thank you very much. And also I would like to thank all the audience for making some questions and comments to us. Thank you very much.
Thank you very much.